Okay, so let me just wait a little bit so that people can join. Okay, good. So if you remember, we talked about logarithmic equations, and now I just probably, if I remember, I gave you two examples, but let me just review what's the point. If you want to solve a logarithmic equation, you need to be able to reduce it into two possible forms, yes? Either, for example, you get something log of a box, I don't know, in the base, let us call it A as usual, and this is something, I don't know, you can put a circle, okay? And assume that something here is missing or something here is missing. So you put it in this simple form, then you know that this is equivalent to saying that A to the power of this circle, whatever inside that, is equal to the box. This is one possibility, and the other possibility is, if you remember, I talked about the logarithmic function to be 1-to-1, yes? So it means that if I have the log of a box in a base A is equal to the log of something else to the same base A, then what is my conclusion? My conclusion is that what is inside here should match with what is inside here. If someone asks you why, because you can motivate that person, not analytically, it's higher than the level of the course, but by using graphical tools, you can motivate why this is happening, because the graph of this logarithmic function is, if A is greater than 1, is something like that. Of course, it means that whenever I draw a horizontal line, I will have exactly one intersection point. So there are no chances. If two logs with the same base are equal, this cannot happen unless these numbers are equal. Yes.
Yeah, then it's injected. But what I want to question that with, can't you also answer log of the box divided by log of the circle? Isn't that a possibility to have that kind of an answer?
Yes, you can have a lot of different scenarios. But you need to be able to use your knowledge about logarithms to reduce them either to this form or to this form to be able to solve it. It doesn't necessarily mean that these are so simple. But this is your strategy to change the form of the log to one of these forms.
That's because in the book they tell us about.
Oh, forget about the book. Okay, so just about this one. Okay, so yeah, so you need, if you want to reduce this, you need to, if you want to solve a logarithmic equation, you need to reduce it to one of these two forms. Okay, either a log is equal to a number, or two logs with the same bases are the same. In this case, you just use the definition of a logarithm. In this case, you use injectivity of logarithm, but forget about the word if you don't like. It means that these two have to be the same. Yes? So let us try to solve some problems. So I would say example. Solve the following equations. Okay, so let me, for example, start with this very simple. So log of x squared plus 3x minus 4 is equal to the log So we want to solve this logarithmic equation. Yeah, it's better to say it because I'm broadcasting on the YouTube. I am using the book called Mathematics 2, written by two Persian authors, Ansari and Qadiri. I have to, in principle, to declare it when I am using it exactly. Yes?
Are these type of questions like are you going to be on the test as well?
No, on the test I will keep the level, exactly the level of the book. Okay? So, yeah, so if you want to make sure, because this is a very stressful year, So yeah, try to start organizing your time so that if you are very ambitious, you have time to finalize the questions in the book. Okay? So usually I consider two cases. If I want to stick exactly to the book, then probably you will not have that much fun using harder problems. But if I cannot ask you these level of questions in the exam, because that's not fair. Okay? So we need to find a combination, a balance between these two. Yes. But of course, I wouldn't consider this even though it is written for gifted students. I wouldn't say this is exactly at the level of the book. It's not hard. I will point you which one are harder. Okay, but this is exactly at the level. Yes.
Isn't that the answer? Isn't the answer -1 plus
I don't know. You want to go through it? I don't know the answers. Might be they have provided the answers. There are two. Yes. So let me solve this one first. First of all, you see that you don't need to do anything for this particular case because this is already in this form. Do you agree? A log. What is the base? It's 10. That is a log. The base is 10. So I have two logs to the same bases, and they are equal. So it means that if I want to solve this problem, it's very simple. What can I conclude immediately? I can conclude that x squared plus 3x minus 4 is equal to 5x minus 1. Yes? And then I am relieved because I already know how to solve this problem if I have done my homework very fine. So this is a quadratic equation. So I move everything to the left. So this becomes x squared. Let us do it in our head. We have 3 x's here, 5 x's goes there, it becomes negative, so it becomes negative 2x. And then I have minus 4, I move minus 1 to the right, it becomes positive 4, it's minus 3 equals to 0, yes? And we already know how to solve this. Is a very simple quadratic equation. So do you remember the formula? Yes, so let me write it once here. So the formula, if you remember, is x is minus b plus or minus the square root of delta divided by 2a. And if I ask you what delta is, you would say it's b squared minus 4ac. You don't need to do it like that. You can combine them in one formula. But try to be fast, Solving a quadratic equation should be a matter of seconds for you, not too much. It's not hard problem, okay? So pay attention to speed as well. So if I want to solve this problem, then let me solve it in my own way. I really don't write the formulas and anything. I have minus b, which is directly to be 2. And then plus or minus, even I don't need to write it that much. Can you do it in your head? Don't do it in the exam. Let us but try to learn that. This 1 to the power 2 is 4. Minus 4 times this one times that one is positive 12. With that 4 is 16. Square root of 16 is 4. So don't waste the time. So just write 4 here. And then 2 times 8, which is 2. Yes, is that understandable? Or if not, I can expand it for you. But it's easy, isn't it? Okay. And then calculate this. So there are two answers. Again, in your head, 2 plus 4, 6 divided by 2. And the other one is 2 minus 4 minus 2 divided by 2 minus 1. But don't be in a hurry. Might be one or two of them, or of course none of them would be a false root. So you need to check it out. Yes, how should I check it? I need to take it back. You don't need to check everything in detail, but you need to make sure that what is in front of the logs actually are positive in this case. So if I put x equal to 3, I don't have any problem here. 5 times 3 minus 1. This part is part of the solution. If both of them are acceptable and you don't explain so much, I can accept it from you. But if one of them is a false root and you accept both of them, then some points you will lose some points. Okay? So x to the power of x3 here, I don't have any problem. It becomes 14. What about this one?
14.
It's 14, so no problems. But minus 1, it's clear. If I put minus 1, I will be in trouble. Yes? 5 times minus 1 minus 5 minus 1 minus 6, it doesn't work. So that's a false root. Okay? So then it means that I go back here. This is acceptable, false. So that's it. That's my solution. Yeah, so I wouldn't consider this actually hard question. The next question is also at the level of the book. So let me write it for you. So 2, it is written log of 10 minus x. minus log of x plus 2 is equal to log of 2. This is exactly a standard level at the level of your book. It's not hard. Okay, I want you to learn the strategy. If you just want to do something randomly, it doesn't work. But you see that my strategy is clear. I told you, you need to be able to change the form of the equation into this form or that form. So this should be your strategy back of your head. So what should I do? Do you have any idea? Anyone else? So you need to have the formulas in your memory. Otherwise, you need the formula sheet in front of you now. Yes, Rupert?
So you could move.
You divide the first logs b by the second.
What do you mean by divide? Can you just elaborate more at home? What do you mean by divide the
Yeah,
log?
you take 10 minus x divided by x 10
Yes.
plus 2.
Yes, exactly. So I would write one log. Because there is a difference between two logs with the same basis, I can write one log. What should I do? I need to divide this by that. Yes? And this is equal to log of 2. I am done now, yes? Do you agree now the form of this equation is comparable to this form? If I ask you what is A, you would say A in this problem is 10. If I ask you what is the box here, you would say this is the box. And if I ask you what is playing the role of the circle, you would say this. So you see, if you do not look inside the box and the circle, you have actually the same strategy, the same form, yes? So then it means that you can conclude, yes?
Something I think is interesting is if the base is not 10,
Yeah.
if it's 5, should I then maybe find the inverse?
No, you need to be patient, little by little, okay? Let me be patient. Okay, so we solve it like that. So, but I just want you to understand, there is a strategy. If you don't have a strategy, then you don't know what to do. My strategy was to reduce the given logarithmic equation into this form or that form. So then I was thinking, is there any formula that I can do this? I got this formula, but this is working now. What can I conclude? What would be the next step? I would say that what is inside the box is equal to 2. Yes, is that understandable?
Yes.
Mm-hmm.
And then, I don't know, let us do it once more. Let me write it. From now on, I will feel free to use these very simple things, you know. If I have two fractions equal, what can I conclude from here? So it becomes A times D is equal to B times C. So this is important to remember. If you have two fractions equal, then this means that this one multiplied by that is equal to this one multiplied by that. In American English, I think they call the product of extremes are equal to the product of means. Meaning that if you have these numbers A, B, C, and D, these are extreme cases, one on the very leftmost one and the other one rightmost one. The product of extremes is equal to the product of what are lying in the mean, in the between. So the product of the extremes is equal to the product of the means. Okay, so I would always use a free to. I will feel free to use it. Okay, I will not explain it all over again. It's very extremely important too. So instead of 2, I can assume that it is 2 over 1. So then I would say that the product of this one and that one, so it becomes 10. Let me write it this way. So then it becomes 10 minus x is equal. I multiply 2 by this expression. It becomes 2x plus 4. Yes or no?
Yes.
Okay, I have minus 2x, move this one, it becomes minus 3x in my head. Yes, 4 minus 10 is minus 6. But then what is x? Is 2. But is 2 acceptable or not? When I put 2 in the original equation, it is 8. There's no problem here. If I put 2, it's 4. That's okay. So that's acceptable.
Baba?
Yes.
Technically speaking, if we do one of these things and we get an equation with one answer, shouldn't it be fair to assume that that answer is valid? Since if it's wrong, we've either done something wrong in the calculations or we're in trouble.
I don't have an example for logarithms in my mind, but I can give you this answer. You see. For example, if I just square it, I get x equal to 4. That's only one answer that I get, but that's wrong. Because if I put 4 here, the answer becomes the square root of 4, which is 2, not minus 2.
So I'm thinking with logs, they can only be positive.
Yeah, these are general arguments. When you want to say something very generic in mathematics, it means that you need to have a real proof for that. Yeah. So this is why I don't dare to say something like that. Yeah. So this is not the case that if you get just one answer, that answer is definitely acceptable, if that's your question.
Yeah, as long as you've done everything right.
Even if you have done everything wrong, everything right. For example, I couldn't give you an example for
So if we say for this case that x is equal to 2 doesn't work, does that mean that the inequality is not true?
No, this means that this equation doesn't have any solution. It doesn't mean it is wrong.
Okay, doesn't have
Because if you have an equation that come up, but you cannot find any answers, you don't say that the question is wrong. You say that this equation does not have any solution, and this sentence is the solution to that problem.
Okay.
Yeah. Okay. So, but is there any other way to do it? Might be, yes. So might be some of you think that, okay, I move this one to the right, even though I don't say it's necessary, but you can also do it. Let me change my color. Before starting doing this calculation, I would say that log of 10 minus x, I move this one to the right. So the log of 2 is already there. It becomes plus the log of x plus 2. This is not wrong. But then what you see that you have 10 minus x, but now there is another formula that you can use on the right-hand side. This time the formula is the log of the product, because I have addition in the middle. Yes? So it becomes the log. I multiply 2 by that. It becomes 2x plus 4. Then what does this mean? It means that 10 minus x is equal to 2x plus 4. So you see that you get this answer again. So it doesn't matter if you want to use it using the division or you want to use multiplication. That's also okay. Is that understandable? So there are two alternatives here for the solution. Okay, let me give you another example. So might be that's a good idea if I wait a little bit. I would say that even this one is not higher than the level. We can consider it probably a level question. Yeah, it isn't actually hard. So number 3. So let me write it for you. And I want to wait a little bit so that you can solve it yourself. So the log x plus 3 plus log of x minus 3 minus log of x is equal to 3 times log of 2. Okay, so let me just wait a little bit for you. So you are supposed to find this unknown value of x. Again, I am working in base 10 according to the examples in this book, but we can change the base a little bit later. Yeah, try to solve this problem. Yeah, you can consider this question a level question if you want to consider the level of the book. And I have the final answers here. So if you got your answer, you can just share it with me to see if you're right or wrong. Yes, I can come and check. According to the book, no.
Does that say x or 2? First of all.
X. You saw this, no? Robert? Not yet. You? No. This is a bad mistake. So you are not allowed to cancel logs. I told you that. So you see, in mathematics, you have to be very careful. Some of you might think that I am canceling log when I wrote this for you. Of course, you are right, but you might think when I concluded that the box is equal to this, you think that I am canceling by log. No, log doesn't have any identity in its own. Log to the base a is not an independent identity. It becomes a number if you put something in front of it. So if you are being tempted to cancel logs everywhere, that is a big mistake. You need to correct it in your head right now. There is no exception. You are not allowed to cancel log. Here I am not canceling the logs. I am telling you that if two logs are equal, then these numbers are the same. So this is not one log. We have 4 logs here. So that method doesn't work. Okay, so no. Okay. According to the book, this is not the answer. Yes.
Could I use this formula here? Is this possible?
No.
Conjugate.
Conjugate root is the square, not the square root. Yeah, it is possible to use conjugate, but you are doing it wrong. No answers yet? Yeah. But what happens to log of x? Yeah, that's also what you have written is not wrong. That's correct. Yeah. No, it hasn't reached the level of deadly. No, you haven't finished it yet. No, that is easier than what you're doing. That's a nice number. No. Did you try the answer? No answers? Yes, Rocco? You just say it loud.
You can just check.
No, you can just say it. Because I want to start solving it. Yes.
So I haven't checked them, but I got the 2 answer. I got 2. I haven't checked which one is right. Then.
That's good.
Oh, is it these ones? Okay.
Can you look at this, Baba?
So you see, you should do it patiently. So Rocco, you are progressing. You see, you yourself feed it, yes? But that's the problem. You need to pay attention. You definitely, this will come. Yes. Okay, so let me correct you. So I cannot correct you if you don't talk to me. So what we were supposed to do this. Can you tell me what to do? What do you want to do? You have a strategy. So you should make 2 logs equal together. Might be you have a variety of situations, a variety of methods. That's up to you. But one way to deal with that is to collect this to 1 log. Can I do that?
Yep.
Okay, of course, if you want, you can move this one to the right. I don't know, use products, but it is unnecessary. This I expect you to be able to do it very fast. I can collect all these logs into one log. You don't need to do it step by step. If you want to do it step by step, I would say that these two are adding together. So this becomes the log of this one plus that one. Then I have a subtraction. It becomes the log of the first one divided by the second one. Yes. Yeah. So what you need to write, what you can write, I hope that everyone agrees. Can you tell me what should I write? Immediately instead of the left-hand side. So you need to collect it back. Okay? It is in the spread form. You want to collect it back. So what should I write? X plus 3
times x minus 3
divided. Exactly. If you want, you can put another pair of brackets around it. It's equal to 3 log of, if I keep 3 here, then I will be in problem.
Log of it.
Yes, because this 3 is actually an obstacle for me. I want to make 2 logs exactly equal, but there is another factor here, which I don't like it, but you know the rule. Yes? What can I write? I can put 3 on top. So I am actually collecting this spread form back. But then if I ask you what is this one, hopefully you haven't forgotten what you have studied in the first parts of this chapter. So do you remember? This is the conjugate pattern. Of course you can multiply, but respect to these rules. If you don't care about them and say that every time when it comes up, I multiply, yes, it will work. It's not a good strategy to do mathematics like that. So what's the answer to this product? It's a very famous product in mathematics. Conjugate pattern, yes?
A to the power of 2 plus b to the power.
Minus.
Minus, yeah.
It becomes x squared minus 9, never positive. And then divided by x. Is equal to log, there is a better name instead of 2 to the 3. People write it 8. Now, you see, so you have a strategy. You want to put 2 logs equal. Be careful. Of course, the next step is this. But the logic is not canceling logs out. Yes, this is not the case. I have this one. And then I can use that rule. Instead of 8, I can imagine this is 8 over 1. And then what I can multiply this by that is equal to 8 by that. Then it becomes x squared minus 8x minus 9 equals to 0. And I have to solve this equation. In general, this is a very simple problem for you. So do you have any questions regarding these steps so far? So I don't know. I would consider it a level question at the level of the book, okay? So what we have to solve this equation. Can you do it in your head?
Yes.
Most parts of it, yes? First of all, to do something in your head, you need to have your formula in a very vivid way in your head, yes? So x squared minus 8x minus 9. So what should I write? X is equal to minus b, which is 8, plus or minus. Let us see if we can do it in our head. This middle one to power 2 is 64. Minus 4 times minus 9 is positive 36. 64, positive 36. How much? 100. The square root of 100? 10. So I can write 10. These things, don't worry. If you are not able to do it in your head, just be patient and write it down. Okay, and then 2 times 8. And then I get 2 answers. What are those answers? 8 plus 10 divided by 2, 9. And the other one is 8 minus 10 divided by 2 is minus 1. By the way, this is not always the case that you should throw the negative one away. Negative one, we don't care. For example, if this was not there and this was not there, minus 1 was acceptable. Why? Because if I put minus 1 here, what I get is log of 2, which is acceptable. The reason that minus 1 is not acceptable is, for example, because of this log or because of this log, not because of that one. Okay, so this is a false root. And then x equals to 9. I do not have any problem if I put 9 here. 9 minus 3 is 6 positive. This is also positive. So yes, 9 is accepted. Yes, is that clear? Okay, so let me. But suddenly they increase the level here. Let me increase it a little by little.
Papa,
Yes.
can I ask you, wouldn't it work if you put it in by that simplification where you put in?
No.
Yeah,
You are not
because-
allowed to put on the simplifications.
No.
No,
it's
that's the
not so.
whole point. If you were allowed to put it in simplification, of course it will work. But you have to go back to the original. That's a crucial thing. I have repeated it several times. Whenever you want to find a false root, you have to put it back to the exact original form, not any one of these
And you have to
simplified
try it on
forms.
every single one.
Yeah, it will work. That's the problem. That's
Like,
the
what if
meaning of the false root.
What if the equation was very long with
So-
a science mathematician?
You have to do it.
The mathematician would like to do that. Like every
Yes.
equation.
Mathematician doesn't care about these kinds of problems that much, but yes, if that problem is too long, you have to do it. Yes. Okay. And then let me see one more question. Okay, let me now give you this question. It is not hard. I don't know how should I evaluate it based on your level, but by the way, I really believe this is your level. Was it hard, really? No. So solve this equation. Log of, let me write x minus 1. This time I want to put 5 minus x as the base. Okay? And then plus another log. I would write x plus 2 in front. The base is still 5 minus x. On the right hand side, I will have the log of 4 in the same base 5 minus x. So you see that here so far we have only worked in a specific base, but here the base is also unknown. It doesn't matter. Yeah, you can also consider it a level problem. I don't think this is hard for you to do it. Yeah, it might be. No, not hard. Yeah, actually, it's very simple.
You can just do it like normally because it's the same.
Yeah, exactly. So this, you know that some of the questions are considered to be higher level because they are not standard problems. Usually, you do not get unknowns in the base. So then you might say that, okay, God, how can I solve this problem? The unknown is in the base, but it doesn't matter at all.
Because it means you need to have a certain understanding of how it works.
Exactly.
You need to understand that it's about the base being the same. Yeah.
Exactly. I will write one more. This I really consider higher than the level of the book might be, but still doable. And if you did that one, you can start here. Don't waste your time. Yes. I have the final answer, so if you are done, you can show it to me. Let me see. So, yes.
If I haven't done anything wrong. I have done something.
-3 is correct, but what is the other one?
2.5.
No, there is no 2.5 here. They have got -3 and 2.
Wait, yeah, 4. It did. Yeah, never mind.
Yeah, so that's correct. But
So
of course, some of them
the
is.
the false root is actually the correct root, and the correct root is the false root in my case, or?
Yeah, you need to check it. I don't know, but your answer is. This is not at least. I think everything is okay. You have forgotten to divide by 2. Because your answers are correct. Yes, but be careful. Might be one of them is the false root. Yes. Yes, if you have time, please start doing the next one. Yes. This is the correct answer, but the other one shouldn't be minus. Okay, so the people who have already finalized this, please continue to the next one. You don't need to listen to me, but let me just solve this for the people. So the people who couldn't solve this so far, what is the first step that I should do? Any one of you.
Should you only say if you haven't done it?
Yeah.
Okay.
So what should I do for this one? Yes, Maxim?
Log the base of x and -1, like in brackets, times the other x plus 2 put in brackets.
Yes.
Then
Because that's the sum of 2 log, and the base should be 5 minus x. That's the same rule. So I would write the log. I will multiply x minus 1 by x plus 2. And then I put the same base 5 minus x. So if you want, I can put another pair of brackets here. It's unnecessary, of course. So here on the right-hand side, I don't have any problems. I cannot do anything. And I don't need to do anything. Because what's the so a log with this base is equal to another log with the same base. This cannot happen unless this one is equal to that one. As simple as that, yes? So I can conclude that x minus 1 times x plus 2 is equal to 4, yes? And then this is a very simple question for you now. So you just solve it and see what happens. Okay, so let us. So x squared. So let me multiply x squared. Here I have to multiply because that's not a known pattern for you. Yes. X minus 1. This is x plus 2. It's not a conjugate pattern or what. So I have to multiply. And then it becomes x squared plus 2x minus x. And then I have minus 2. I have this one equal to 4. But this becomes x squared. 2x minus x is just simply x. I move 4 to the left. Minus 4 minus 2 minus 6 is equal to 0. And this is a quadratic equation. This should be a matter of seconds for you, I told you. So this should be minus 1 plus or minus. What would be the answer that I have to write here? Can you do it in your head? So b to the power of 2 is 1. Minus 4 times this times that is positive 24. 24 and 1, 25. The square root of 25 is 5. But you don't need to do it if you don't like to do that. Multiply, divided by 2 times a. So these are the answers. And this is easy to do it in your head. Yes, once you use the positive sign, minus 1 positive 5 with positive 4 divided by 2 is 2, and the other one is x equals to minus 6 divided by 2 minus 3. Which one is not acceptable? Definitely minus 3 is not acceptable. Why? Because if I put minus 3 here, both of them are negative. But be careful. So this is a false truth, definitely. But what about 2? Is it acceptable? Yes. But you also have to check the base. It's important, yes? If I put 2 here, it becomes positive. Sorry. If I put 2 here, it becomes positive. If I put 2 here, it becomes positive. But you also have to check the base. Be careful. If I put 2 here, the base becomes 3. 3 is acceptable because it should be positive and not equal to 1. So everything is safe if I choose x equal to 2. So it means that my answer is x equal to 2. Is that understandable? Okay. But the next one might be it's a little bit above the level of the book, but I can consider it a level again. Yeah, please solve it and show your answers to me. I think I also have the final answer to this problem here. Yes, or no, I don't know, but at least. Yeah, yes, I have it. So I would say that if you can solve this problem, you actually know 90% of what we said about the logs, yeah? Because you have to use a lot of formulas here. Okay, so you are in the middle of the way. I want to write a challenging one for you here as well. So this I will consider really above the level of the book, but still I want to solve it for you to see that you can solve it as well. I will write a challenging one here, okay? Yeah, if you did it, show your answers to me and then continue here. Might be this one is challenging. No one did the previous one yet?
Oh, I'm on my way to doing it. I
Okay.
know what to do.
I seem to be getting a fraction. Is that an answer? Or is that
No, the answers are not fractions.
No.
This is a Persian tradition. They care about whole numbers. I don't know why. So they design question in a way that you don't need calculators because the calculators are not allowed. So that's the problem. Let's see how much. Which one?
Number 5.
Number 5. Let me double check. Yes, what are your answers? No, everything is correct, but your final answer, because this equation is exactly the equation they got. Equals to 0, don't forget. But no, you made a mistake in calculation. Yeah, everything is fine. That's very good. Yeah, thank you very much. Yeah, so we have one correct solution for number 5. So first of all, you should have this feeling that something is going wrong. The reason is that you need to know third-degree equations are hard to solve.
Yes.
I'm not saying that they cannot happen, but if you are facing a third-degree equation, I would say that let us stop and revise the calculation. If everything is okay, then continue. So these are the experiences that I'm just teaching you. So third-degree equations are not standard equations at all.
So could you help me where I went wrong in that?
You need to find it yourself. I understand what you have done.
Okay.
So, yes, everything seems right.
So I have done everything right so far.
So, but you did it in a way that it gave rise to a third degree equation, which is hard to solve. That's a little bit unfortunate because what you have done, I understand what's your mistake.
Okay.
This is negative.
It's
not product.
Oh.
It's division.
Oh.
Yes?
Yeah, okay.
Yeah, that's the mistake.
Yeah.
Alexander, how is it going? Yes. Yes, Robert, could you fix it? Could you detect your mistake? So this 1 to the power 2 is this one. 4 times this one is that one. What is the number? 936. 336.
Yeah.
Yes?
Yeah.
You can check it with the calculator. So how did you make mistakes? I don't understand. This is 64 now. So it's 64. So we got this for 64. So the answer you showed me was wrong because probably you have forgotten to divide by 2 then.
No, I'll just put it
Yes. But anyway, but this you need to improve your skills of calculus because that's an extreme pity if you cannot get the full marks on such a question because you did the hard part but you are making mistakes. You need to improve these skills. Yeah, you need to pay attention. So you have to love calculations. You know. Yes. So yes, could you start with this challenging one, Cameron? Did you solve that challenging one?
Close.
Yeah, good. Can you show me? Yes. Yes, might be one of them is false, but these numbers are correct. Thank you. We have the second solution. We have the second solution. Yes, good. So Abdulmanan, you are silent today. Are you tired? No, because you were doing great actually before this. So what's going wrong? You see, these are not mistakes because of this new lesson, because of the old lesson. You cannot put 1/2 on top of this and on top of that. Yeah, so these are this. You know what's the problem? The problem is coming from the formula sheet. No formula sheet next year, by the way. I really decided about that. What is the meaning of formula sheet?
think so.
Can you show? I don't know the answer. Let me check by the book. Okay, you can show me the answer.
I didn't check it.
No, you don't need to check. Just answer and assume that it's next. Yes. Thank you. So Cameron solved the challenging one. I'm trying to pit you against each other, yes, but that's a good attitude.
I'm fine with you doing that, but maybe not against Cameron. I mean, that's a bit unfair.
Okay. Oh. It's not unfair, but what is your age? Are you the same age?
So it is completely fair. Yeah, but he knows more stuff. Okay.
You can. No, I would say the difference is not knowing more stuff because you don't need more stuff at this moment. Might be that was a little bit of American style to learn things. I don't know, but
Well, I mean, it's making me learn. So I mean,
yeah, that's what I'm saying. You need to try to learn because what Cameron is probably using for solving this problem is exactly at the level of your knowledge. But I want to change the habit of your studies. If you want to, it's possible. So the books are really underestimating your level, intellectual level. Try to prove them they are false. They are actually wrong, yes? This is actually also very challenging, I think. Let me write this one as well here. So, log of x to the base 3 plus log of x to the base 5 is equal to the log of 225. This is a very simple equation, but I will consider it challenging because not all the bases are the same. Yes. Okay, so let me solve this one for everyone here. Do we have more answers there or not?
Yeah. 1 second.
I'm almost done. I just need to solve the.
Okay, I can wait 2 more minutes. Okay.
Yes, then I'm done. This is my answer.
Pardon?
This is my answer.
That's 14
6 don't go in
and
here.
6. Yes, but are both of them acceptable? I think they are. Yes, if you put 6. Positive. Mattias, how is it going?
Eller jag tror det. Vad jag dock fel.
I'm sure it's somewhere there.
So what happens with this one? What's your strategy with 1/2?
I mean,
Okay, on top of that.
Yeah.
So where is on top of that? Don't see. You're right. That's your mistake. Yes.
About the left-hand side.
Hold on, we made a small mistake here. Yes.
So with the left-hand side, can't you do this?
Yes.
Hold on.
You can do it. Okay, so now let me solve this problem for you. The people who actually couldn't solve this problem, you need to take lessons from your mistakes. You have to be very active in classroom. You need to give yourself feedback. This is not something that any teacher can do for you. You need to do it for yourself. So let us see, how can I solve this problem? Do you have any problems on the left-hand side? In principle, you shouldn't. Let me write every detail here today, this time. So this becomes log. I cannot do anything with the first one, so let me just copy and paste it. But you know that your goal is to collect everything back, okay? So I need to do something with 1 over 2. What is the only thing that I can do with this 1 over 2? Because that's an obstacle. If this 1 over 2 was not there, then log of this one minus of that one, there is a formula. I can use it. But because of this 1/2, I cannot immediately use that. So as Ali actually pointing out, you need to put it on top here. It's not hard, yes? So the goal, the strategy is collecting these things back. So this becomes what? 2x minus 3 to power 1 over 2. And then what do I have on the right-hand side? The right-hand side might be a little bit problematic in this form. If you want, you can move log 25 to the left. And then it becomes a product. It becomes plus log of 25. But let us intentionally not to do that, because I want to teach you something more. If you want, you can move this one to the right. It becomes plus log of 25. So it becomes plus log of 25. What happens? What happens? I don't know. Might be it is a good idea to solve it in 2 different ways. Because it's really important to solve problems in different ways. Then you will learn. So one strategy is to move log of 25 to the left, and then it becomes what? It becomes 2. Now, can you help me to collect everything in one log? I have the log minus another log plus another log. The good point is that all of them have the same basis. Can I collect them into one log?
Yep.
Yes. So now you understand why that was a good idea to move it to the left. Yes? So you need to understand. So what can I do? I can write the log of x plus 6. Do I have a better name for this guy?
Square root of.
Yes, instead of putting 1 over 2 up on top, let me write the square root of 2x minus 3. And then, oh, sorry, this should go to the denominator. And then what is left in the numerator is still a 25, exactly. So what is right on the right-hand side too? So you see, I collected the log into one log. And that's the standard form, yes? Who cares about this? The log of this number is 2 in the base 10. So what is this guy?
100.
100, because the log of 100 is 2. Yes? So this means that 25 x plus 6 divided by square root of 2x minus 3 is how much?
100.
100. Agree? Yes or no?
Yes.
So you see, this is one strategy. I moved it to the left. Then I saw that I can collect every log into one log. And then I am done. But I mostly believe that you start multiplying 25. Don't do these bad things. These are crimes, you know? Respect, because you are only relying on your calculator, you don't respect these things. But I will never continue with 25 and 100. Because I can simply divide by 25. 25 is totally gone. And this, instead of 100, becomes just 4. Of course, if you don't do this, it will work. But then you have to do a lot of more heavier calculations, yes? So what should I do? If you don't mind, let me continue here. I don't want to clean this. Okay, so what is left for me is x plus 6. The square root of 2x minus 3 is equal to 4. This equation, if you were able to come up to this equation, it means that you learned everything about logs. But if you cannot solve this one, it means that you have forgotten what you have learned about root equations. Yes?
Wait, so 100 is also a numerator and 25 is also in a numerator. How did you simplify them?
No, because one of them is on the left, one of them is on the right. By simplification, it means that I divide both sides by 25. I divide this by 25, 25 is gone, divide by that one. So what you are asking is one in the numerator, it is what the same fraction. They are on two sides, one on the left, one on the right. Okay? So now, how should I solve this problem? This shouldn't be hard for you to see this. 4 times 2x minus 3 is equal to x plus 6. Do you agree with me? I give a denominator 1, multiply this by that, equals multiply this by that. But do you remember what was the main strategy in solving root equations? I have to get rid of the square root sign. What can I do? So I square it. When I square it, there are 2 terms involved. So this will be squared, which becomes 16, and this will be squared. The square root sign is gone. On the right-hand side, it becomes this 1 to power 2. But then it becomes, I multiply 16, it becomes 32x minus 16 times 3 is 48. On the right-hand side, x to the 2 times the first one times the second one, and the second one to the 2. You see, I am just doing simplifications. Yes? And then let me move everything to the right-hand side. X squared is already there. 32x moved to the right becomes minus 32. There is a 12 there, it becomes minus 20. Minus 48, move it to the right-hand side, it becomes positive, and positive, it becomes 84. So this is your equation. And then you have to solve this equation. So I consider it a higher level because you also need to remember yourself about root equations. So if you can solve the problem, this logarithmic equation reduces to a root equation, and then you have to write and solve that root equation. Yes? So how should I solve that one? I square it, and I got a quadratic equation. And then I can solve this quadratic equation. So let me just do it here for you. So can you do this one in your head? Minus b. What is minus b in this case? Everyone. What's minus b? 20. Okay, can you do the other parts in your head? So if you don't, you can just do it in scratch paper. But this 1 to power 2 is not hard. What is that? 400. 4 times 1 times 84. What's that? 480 is 320. 4 is 16. So it is 336. So it's minus 336. 400 minus 336 is 64. Square root of 64 is 8. So you can just write plus or minus 8. And then divided by 2 times 1, which is 2. And then you get 2 answers. 20 plus 8 is how much? Is 14. And the other one is? 6. So 14 and 6. Yes? So if you go back, if you put 14 here, you don't have any problems. Do you agree? If you put 6 here, you don't have any problems. Yes? Yes?
So, may I just ask, like, okay, I've done it from another strategy, but it feels like it's right, but I didn't get
I want to do it. What is your strategy?
Okay, so I said that instead of writing 2, I said
that's the second strategy.
logarithm
Yes,
of
exactly.
100, and then instead of log of 25, I said log of 5 to the power of 2, and then I moved log of 100 to the right hand side, and then I moved.
No, you made it so complicated.
But no, hold on. That's 5 to the power of 2 there, and we have a 1/2 there.
No,
Like,
I want to talk about your strategy. That's completely correct. Here in this strategy, I moved log to the left. But as Casual said, what can I write if I don't want to do that? Remember, that's also a good technique to remember. Put it in your toolbox. What can I write for 2? In the base 10, can I write this as a log? Yes, I can write it as log of 100. Might be it looks a little bit strange. Why 2 is more familiar for us than log of 100? So why should I change 2, which is more familiar for me, to log of 100? Because then log of 100 minus log of 25 can be written as log of 4. Yes, because 100 divided by 25 becomes log of 4, and then I can collect this in 2 4. So I can collect it in this way. I can collect it as log of x plus 6 divided by square root of 2x minus 3 is equal to log of 4. And then I am done. This means this number is equal to 4. And that's exactly the equation that I got here.
But even from the more complicated way, it should give the answer.
Yes.
But I didn't get.
Yeah, I will check your answer. But this, please, I want to teach you this one. Sometimes you need to change a simple number to a little bit more complicated one because it will solve your problem. Okay? The reason that I chose this strategy because might be this seems a little bit strange, but by the way, you see some of these things in the book. There are some exercises, very simple exercises, that if you want to solve them, you have to change the form of the very familiar number to a little bit more complicated form. Because if you think in that way, my goal was to make this a log. So let me tell you this. For example, can you tell me how can I unite these two logs? For example, 1 minus log of 2 to the base 3. If I want to write it as one single term, how should I do that? How many terms are there? 2 terms. One of them is 1, the other one is this log. I want to write it as one term, yes?
You can write 1 as a log of 3 in base 3.
So you see, when you understand what's going on, it's not that hard to do mathematics. If you don't understand what's going on, it becomes horrible. Yes? So you see, I talked about log of, so because Rocco understands the strategy, so he was able to understand that here, I shouldn't write 2 in base 2, 5 in base 5. All of them are correct. But why he chose 3 in the base 3? Because he saw that there is a 3. And now what we can write? You can write the log of 3 divided by 2 in the base 3. So how many terms are involved here? 2 terms. 1, the second one. How many terms are involved here? Only 1. So sometimes you can use this trick to collect the log back. Okay? Okay, so I will keep these questions. Might be we can at some point solve some of these problems. I want to use them somehow to teach you the strategy of tackling problems. And I want to see how. So if you want to feel, if you cannot solve this, you shouldn't be able to sleep. If you don't have this feeling, your mathematics will not grow. Okay. So there should be something in your brain prevent doing something if you don't know the solution to this. So what I'm saying, if you don't have that feeling, you shouldn't expect that your mathematics be very strong. There should be something in your brain preventing you to go to sleep before solving this problem. Okay? Or at least try so hard to solve the problem that you fall asleep. To fall asleep, yes. Yes, this usually happens for me. Most of the time I sleep behind my desk. Yes, I don't know, I resist to sleep. Of course, this is not good because if you are sleepy, your brain doesn't function very well. But anyway. Okay, no questions? Yeah. So this problem is also, I would consider it challenging, even though this looks simpler than this one, but I would say this is a little bit harder. Okay, so yes, please try to solve these problems, but I want you to believe that your mathematics will grow if you pay attention to it. And then math would be a very interesting subject. This is the only math, probably that's the only subject that you don't need to study on the exam day. Because what's the problem? If you want to, if you can solve the problem, okay, that's it. And if you cannot solve the problem, you cannot solve it even in the exam. So it's better not to study, okay? So, okay, thank you very much. We are finalized with this chapter, okay? Yeah, thank you. Thank you very much, people at home. I will end this stream now. Thank you.
So tomorrow you start with the next chapter?
No, I will give you 2